Today we are going to discuss about linear programming problem part 3 from the formulation of problem. So welcome to my YouTube channel Mechanical Engineering Management. Like, share and subscribe. So in this video we are going to focus on formulation of the problem from the description. So in this video we will discuss two problems so that you will be able to formulate mathematical model from the description. So let's start from the first problem. Consider two different types of foodstuffs, say F1 and F2. Assume that these foodstuffs contain vitamin A and B. Minimum daily requirements of vitamin A and B are 40 mg and 50 mg respectively. Suppose foodstuff F1 contains 2 mg of vitamin A and 5 mg of vitamin B, while F2 contains 4 mg of vitamin A and 2 mg of vitamin B. Cost per unit of F1 is Rs 3 and that of F2 is Rs 2.5. Formulate the minimum cost diet that would supply the body at least the minimum requirement of each vitamin. So first of all, try to understand the description. So two different types of foodstuffs, say F1 and F2. So we have to take the decision over here for the two different foodstuffs. And so the two decision variables are there for F1 and F2. The important part is over here. The cost is given to you, 3 and 2.5, and so that it is the minimization problem. So your objective is to minimize the cost. Formulate the minimum cost diet. So we have to generate the mathematical model to minimize the cost. Simultaneously, the minimum requirement of each vitamin should be supplied to the body. This is the description given to you. So here decision has to be taken on how many quantities of product F1 and F2 to be included in diet so that your cost should be minimum. So let's say X1 is the units of F1 and X2 is the units of F2. So here I have written X1 is for the F1 and X2 is for the F2. So if single unit of F1 and single unit of F2, then my total cost is 3 plus 2.5. So in generalize, I can say Z is equal to 3x1 plus 2.5x2. So my objective function is related to the cost. So it should be minimize Z is equal to 3x1 plus 2.5x2. Now constraint. For vitamin A, minimum daily requirements are 40 mg. So here it is given to you, minimum daily requirement for vitamin A is 40 mg. And so that I can write over here constraint for vitamin A. Now once again look at the description. For the vitamin A, food F1 contains 2 mg and F2 contains 4 mg. So I can say 2 into x1 plus 4 into x2. And this total must be greater than or equal to 40. Because of this is written over here, minimum daily requirement is 40. So it should be greater than or equal to 40. Now the second constraint for the vitamin B. So that is given to you, the minimum daily requirement is 50 mg. So I can write over here constraint for vitamin B. So look at this description. 5 mg of vitamin B from the food stuff F1 and 2 mg of vitamin B from the food stuff F2. So simply you can understand 5 into x1 plus 2 into x2. And once again should be greater than or equal to 50 because of it is the minimum requirement. And at last I can write the non-negativity restriction for the two decision variable x1 and x2. Second, a dairy plant packs two types of milk in pouches, that is full cream and singleton. There are sufficient ingredients to make 20,000 pouches of full cream and 40,000 pouches of singleton. But there are only 45,000 pouches into which either of the products can be put. Further, It takes 3 hours to prepare enough material to fill 1000 pouches of full cream milk and 1 hour for 1000 pouches of single tone milk. And there are 66 hours available for this operation. Profit is rupees 8 per pouch for full cream milk and rupees 7 per pouch for single tone milk. Formulate it as a linear programming problem. So look at this description. The very important point over here is two types of products, and so that you can understand, simply there are two decision variables. One is for full cream and another one is for the single tone. One more thing, over here profit is given to you, so your nature of objective function is maximize. So this is the description given to you. Here decision has to be taken on how many quantities of product full cream and single tone to be produced. So here I can say x1 is the units for the full cream and x2 is the units of the single tone. So over here x1 and x2 are the decision variables. So here I am going to write x1 is for the full cream and x2 is for the single tone milk. Now if I produce single unit of full cream and single unit of single tone milk, then my total profit is 8 plus 7. So I can write over here Z is equal to 8 plus 7 if I produce single unit of full cream and single tone. So in generalize, if I produce x1 units for the full cream and x2 unit is for the single tone, then my total profit is 8x1 plus 7x2. So I can write over here objective function maximize Z is equal to 8x1 plus 7x2. Now look at the first constraint. For pouches, total units are limited to 45,000 and that is given to you over here. There are only 45,000 pouches into which either of the products can be put. So the total number of pouch are 45,000 only. So that is the constraint for the pouch. So I can write over here x1 plus x2 less than or equal to 45,000 because of this is the maximum limit for the pouch. Now next, for full cream, total units are limited to 20,000. So that is given to you over here. There are sufficient ingredients to make 20,000 pouches for full cream. So that is once again limitation for the full cream. So I can write over here constraint for the full cream as x1 less than or equal to 20,000. You can understand x1 is for the full cream. So number of units for the full cream should be less than or equal to 20,000. Now for single tone, total units are limited to 40,000. That is also given to you in your description, 40,000 pouches of single tone. So I can write the constraint for the single tone as x2 less than or equal to 40,000. Now next, constraint is for the hours also. Total hours are limited to 66. That is given to you over here. There are 66 hours available for this operation. So I can write the constraint for the hours. So try to understand why it is x1 upon 1000. So in the description it is given to you. It takes 3 hours to prepare enough material to fill 1000 pouches of full cream milk. So if I consider hours required per unit, that is x1 upon 1000. Similarly, you can understand over here x2 upon 1000. And at last, non-negativity, that is x1 and x2 must be greater than or equal to 0. So thanks my dear friends. Press the like button to appreciate this video.